What is up, most distinguished patrons of this channel? Today we are going to go on an adventure of a repair, and well, by repair I mean a crack repair, and we're going to be talking about that and everything to do with it. So let's get started. So I went through the archives of photos that I haven't shared with you guys and came up with a pretty interesting job that I did to repair part of a garbage truck. And so much of this job is actually relevant to, I think, what a lot of you guys might get into for repairs. And there's a lot to be learned on this, so that's why I'm sharing it. So anyways, this picture that we have here is not what I repaired, but it's a better picture than I took of the actual repair job, more or less what we're actually working on. So what we have here is what's known as a packer blade. It's more or less a really thick, heavy-duty steel wall that's hooked to two hydraulic rams, and the rams use that wall to compact garbage in the back of a garbage truck. So pretty nasty, pretty filthy, and they apparently break a lot, far more than I would have expected, especially because they're made out of pretty thick steel and generally have pretty decent welds on them, but hey, failures happen. So we're going to be looking at a failure of this part right here. Where the arrow is pointing is where I found a crack, and what had happened was I was doing an inspection for some unrelated thing on this. I can't remember what I fixed, something on the side maybe, and I just happened to walk past the back, and keep in mind this stuff is so full of filth that like you can't even pressure wash that gunk off of that blade. But I saw what appeared to be a line in the gunk, and that's something you never want to see. If you have like really thick filth and then a clear, distinct line, 9 times out of 10, that means there's a crack underneath it, and it follows the trash, the gunk, all the way out to the surface. And I'll show you a picture of that now. So this is after I cleaned it enough to verify it was a crack, but if you can imagine, that consistent filth there, and then you see a black line that's reasonably straight, like I said, 9 times out of 10, you're dealing with a crack in the steel that's underneath it. And I happen to have caught this, and rather than, being the typical person and probably just acting like I didn't see anything, I decided, well, if I don't fix it now, it's only going to get worse and I'm going to have to fix it down the road. So I decided to take it upon myself to fix it right then and there. Took me about, I don't know, a whole day to do this job because I was doing a lot of other work besides this, but you'll see what I did in this. So anyways, step one is more or less to clean this the best you can. Now, I'm not joking when I say that Hotsy, a hot pressure washer, barely was able to clean the filth off of this thing. That stuff is better than powder coating. It's so hard to remove. You almost need like abrasives and wire wheels to get it clean. But step one was basically to clean all of this crap off the best of my ability. So once I got this cleaned, I noticed something. This is clearly not an OEM or factory weld. This was already repaired in the past at some point because the other side didn't look like this. It didn't have multiple stringer beads, and the welds overall were far cleaner on the factory side. So this was clearly repaired, and that's generally not a good sign because it means, well, it cracked once and then somebody repaired it and it cracked again. Now, my repair on this, I believe, will last and it won't crack again for numerous reasons, which I'll talk about later. But this is not a good sign, and I don't like seeing this. I rather see a failed factory weld than an attempt at repair, because guess what? All of that material needs to come out because it's all suspect now. This picture gives a lot better idea of the quality of welds that we're dealing with. The previous picture made it look better than it really was, but you can see here that they're just kind of goobered in there, and you can see how that crack more or less follows the toe of that weld. Now that weld, being that it was run vertical up and fairly poorly, had a lot of undercut at the toes, and guess where the crack ran? Right along that undercut. pretty typical and to be expected. Now, if I had to take an educated guess, I believe that somebody saw the crack and rather than cutting it out, putting new steel in and properly welding it, they more or less just buffed the surface and ran a bunch of passes on it trying to clean it up, and this was the end result. I don't believe that they tried to at least put some new steel in there, which they probably would have had more success. But, this is what you commonly deal with in the repair industry, and you got to be careful. Like, if someone came to you and wanted this repair done, you got to think to yourself, you know what, I got to cut all this crap out and start out new. Don't just grind it flat and weld over it. The crack will come back. So at this point, I made the decision to torch gouge a bunch of the material out. As you can see on the vertical up on the left side, I cut that whole section strip out about an inch wide or so. I left that little attaching point at the top of that. I did actually remove that later. My number one goal at this point was to leave that attached so that hopefully nothing moved. And what I ended up doing was cutting 2 holes in that vertical up piece close to where I gouged all that out in order to tie in a plate behind there, and I'll show you what that looked like. So as you can see here, I cleaned it up even better than what it was, have the 2 holes torch cut right through there, and again I left that top left corner there just to kind of somewhat hold everything in position. I don't want anything to be moving unless it absolutely has to. So my thought was, by slipping a plate behind this, about 1/4 inch thick material, and then doing 2 rosette spot welds and then tying everything in on the left side, I know that I have decent quality material. All of that former weld is all gone. And what I find is when you get a crack in steel, odds are it's fatigued, and near that crack is also going to be fatigued metal that likely has internal cracks. And by at least cutting a lot of that out, you're dealing with cleaner material, especially because when I welded everything fully out, kind of like a multi-pass, like almost backing strip kind of weld, everything's clean new metal, and it's highly unlikely that it would crack again in that location, primarily because I didn't just weld over a crack and think that it's going to hold. In case you're wondering why welding over a crack generally doesn't work, especially on thicker steel, is a lot of people, they have this illusion that somehow like stick or MIG or TIG or any real welding process has like super good penetration. And the truth is that you don't have much penetration at all. And when you try and weld over a crack and you're not actually fusing, half or 2/3 of the way through the material, you basically have a perfect point that for the stress to focus, and therefore it will just re-crack right there, especially because something like this that has huge hydraulic rams and a ton of force and flexing, you can't afford to have what amounts to a lack of fusion, because that's what the crack really is. You don't have a tie-in between the 2 pieces of metal, and when you have that and things flex, it's gonna flex at that point and it will break through whatever BS weld you put on top of it. Icing on a cake might be good, but you don't want to do that with your welds. So here you can see I slipped that plate behind there. I just tack welded on a triangle piece to hold it in place. Sometimes I'll use a welding rod and tack that on there depending on what, the constraints of the job is. But that's a 1/4 inch plate from what I remember, and I'm going to fully weld that to the left side of that. I'm going to weld it all the way out, so fill that whole low spot in, and then of course the spot welds, rosette welds, to help tie everything in a little bit better as well. And this is my method for doing something like this. You may have a different idea on this. Realistically, I could have cut out more of that material to the right and just did a flush plate on that and did an open root, but I don't find that that works that well with stuff like this, because one, it's absolutely filthy material even though I cleaned it. Like I wouldn't say it was zinc treated, but I'm telling you, man, this stuff is a pain in the ass to weld on. So you're not TIGging this. You're probably not MIG welding it either. You're down to stick welding, And with stick, trying to do an open root vertical up with 7018, and not do what I did where you're layering plates is kind of a lost cause. You're not going to be able to do that too well. And 6010 really has no business on a job like this because of the stresses involved in it. I think that the brittleness of that and the lower strength would lead to failure. So really, this was the best option and it worked out good. So here's the first pass on the left side. I tied in that backing strip into the sidewall there, done vertical up, ran somewhat okay. The base material, man, even though I pressure washed it and wire wheeled it, it didn't weld the best. So I have the left side tied in and I did spot weld the bottom of those plug welds. So that's looking really good. And basically I just have to fully weld that out most of the way anyways. And this is what that looked like when I was mostly done. So the spot welds are welded out real nice. The vertical up welds are all layered in there. It's tied in really nice, over flush. And realistically, there's more weld there than what's needed, but that's all right. Sometimes it's better to over weld than under weld and pray it holds. But based on what I see here, I like everything. It's all tied in nicely. Now what I'm going to do is go on the top of that and I'm going to cut what was left there out and then put a square plate in, much like I did here. So it's a little bit hard to see, but I cut back quite a long ways in that. And I also opened up a hole for a plug weld there on the right. And with all of that removed, which I could do because the whole left bottom there was all stabilized because it's tied in, I basically slipped a plate in there and then tied it into the left side and also did an initial pass on that plug weld and a little bit around the right edge there. And that's all tied in together. And now's the time to basically fully weld that out. So at this point, it's mostly welded out. I still have to put a couple more passes on the top of this stuff to bring it out above flush, but it's looking pretty good. Now, the crack did actually continue down around that corner there that you can see in the upper middle of the picture where there's like a black dot. I cleaned that out as well with the torch, and I ended up doing the same thing that you see here where I put a plate in there and welded it fully out. It kind of hit a point where it opened up and it had a tie-in that was, how do I put it? It like wasn't fully welded from the factory to where if it cracked, basically the crack ended a little bit more further than what you see there, I guess is the best way I could put it. And so no more repair was needed other than maybe an inch around that corner there. Because I couldn't get a camera in there, I didn't take a picture or pictures of it. But based on what we have here, it's ready to be wire wheeled, cleaned up a little bit, and a couple more passes put on it just to bring it out past flush. And this is what the completed job looked like. The top was brought out past flush. Everything looks tied in, looks real clean. Not too bad of a job considering what I started with and doing the vertical up welds. I mean, don't get me wrong, when you stick weld enough, vertical up isn't really that big of a deal, but I was running 1/8 inch rods, and if you know anything about stick welding, it's a little bit harder to run 1/8 inch rods than the 332s. So tip for anyone who wants to learn how to do vertical up or just improve their vertical up game with 7018, you want to stick with the 332s. It's a little bit easier than the 1/8 inch rods. But yeah, based on where things are at here, I'm going to wire wheel this up as best as I can, put some primer on it, give it a coat of paint, and send it off on its way. It's looking pretty much ready at this point. And here is a completed job. It's all primered, and I probably threw a coat of paint on it or something. I don't remember. But anyways, what did we learn today? Well, we learned that doing inspections is pretty important, and no matter what the filth, if you see straight lines, definitely do a little bit of investigation. You might find something you didn't expect, like I did in this video. Now, this is a repair job that really isn't that difficult or beyond the ability of anybody with some kind of welding skill, but you got to understand that if you can't put down clean welds in a vertical up position. You need to work on that and practice in order to get good enough to do something like this, because a ton of repair jobs you might run into, or something you yourself broke on maybe your farm or whatever, you might not be able to reposition it to where it's easier to weld. So you might as well get good at running vertical up, simply because you're going to have to at some point. But like I said, this isn't that hard of a job, and if you're just smart about things, you can definitely do something like this yourself. And honestly, based on how it turned out, I'm pretty happy with it. I don't believe that it's ever going to fail again. The truck will be likely in a landfill, no pun intended, long before this repair fails. Now, that might not always be the case. Something like this, if it's stressed beyond what it was originally designed for, it's entirely possible that even a decent repair like this would fail as well. And that's something that I kind of mention in a lot of my repair videos is, the loose cannon at the wheel is something, you'd be amazed what somebody can break. Like, I could have put gussets on this and all sorts of stuff trying to make it stronger, and then some idiot would still break it. So, you can never really eliminate the idiot behind the wheel with any kind of equipment breakage, but you can at least do a good job on your repair to where you're not leaving like undercut and just welding over the top of stuff and, praying that it's going to somehow hold. And in the previous repair video I did, I also mentioned something that's called over reinforcement. And that's something that a lot of people don't talk about, don't know about, or don't really consider. And this is a good example of, if I would have welded a bunch of gussets on this and made it like overly stiff, odds are it would break somewhere else. Like, this needs to have a certain level of flexibility so that all that stress doesn't just get put into one point. And you want to be very careful when you like over reinforce things with gussets, because you likely are going to break something else doing that. And I know, it might be hard to understand that, how making something stronger can actually make it weaker, but you got to understand, like, this is more or less an equal force distributed on this whole blade, this whole hydraulic wall. And by making one side of it stiffer than the other, odds are it's going to flex more on the other side, therefore it's going to break there. Reinforcing it wouldn't make it weaker where you're reinforcing it, but it may make it weaker overall due to poor engineering. So something to be aware of. Anyways, if you got any comments, questions, thoughts, opinions, feel free to leave them. Otherwise, until next time.